In this example, we're looking at finding stationary points on a more complicated function, y equals 2x cubed take away 3x squared, and we have to determine their nature. So as before, we differentiate, multiply down by the 3, reduce it by 1, then multiply down by the 2 and reduce it by 1. So stationary points occur when the dy by dx equals 0, or the derivative equals 0, i.e. the gradient's equal to 0, so we let this here equal 0. Now to solve this is a bit trickier than the ones before. We have to factorise using our int2 or national 5 work. So to factorise this, we either have to do a common factor, difference of two squares, or a trinomial. Now I can see that 6x is in both parts, so I'll take that as a common factor, and in my brackets I'll have an x, 6x times x is 6x squared, and then take away 1. We can now solve this, so x can either be 0 outside the bracket, because you'd get 0 times negative 1, and that would come out as 0, or x could be 1, because you'd have 1 take away 1, which makes 0 in the bracket, and that would be 6 outside, so 0 times 6, that would be 0 as well. So 0 or negative 1. So we've got two stationary points this time. We now have to find the y coordinates of these stationary points by subbing these back in to y equals 2x cubed take away 3x squared. So to get the first y value, you're subbing in 0 here, and that just comes out as 0. And then you're putting 1 in both parts. So that's 2 times 1 cubed take away 3 times 1 cubed, and that's negative 1. So now we have to do two nature tables. Some people do it all in the one nature table, which is absolutely fine. I just prefer to do it on two separate nature tables. So our stationary points are 0, 0 and 1, negative 1. The first nature table, I'll go for the stationary point at 0, and the second one, I'll go for the stationary point at 1. That's the x values we use here because we're looking along the graph. Now, we have to look at the values round about 0, so I'm going to use negative 1 here, and I'm not going to use 1 here. The reason for that is because you'll be taking a value from the other nature table. It's easier to look at the graph to understand this. This is the graph. We have a stationary point here and another one here. Now we're looking at the stationary point at 0. We want to know what's happening just before 0, so we're looking at negative 1 here, that's fine. And we want to look at what's happening round about here, whether that's increasing or decreasing. Now between these two values, 0 and 1, you're trying to find out what's happening. So we don't want to go all the way to 1 because that's when your next stationary point's occurring. So we'll go halfway between 0 and 1 to find out what's happening in this wee section here. So that's why we're going to use a half. Now we want to look at what's happening in the second stationary point. So just before the stationary point and just after. Just after doesn't really matter, but just before we'll use a half again. And just after, I think we'll use 2. If we can use whole numbers, we will, but we can't use whole numbers for these values here because we want to look at what's happening between 0 and 1. So everything else is the same. We just do our nature tables. So we're going to have 0 gradient at the stationary point and 0 gradient at the stationary point. We're then going to substitute negative 1 and 0.5 into the derivative, which is 6x squared take away 6x. We'll do that below. So x is negative 1, so y by dx equals 6 times negative 1 squared, and so on, and that comes out at positive 12, so that's positive. At 0.5, we'll substitute it in, and that comes out at negative 1.5. So we have a negative. So that's an upward slope, and then the stationary point, and then a downward slope. So at 0, 0, we can see that's a maximum. So maximum turning point is 0, 0. And we've already worked out 0.5. You could do it again, but we've already worked it out as negative 1.5 from down here. And then we'll put 2 into the derivative. Remember, the derivative is this bit here. So subbing that in, we get 6 times 2 squared, take away 6 times 2, and that comes out as 12. So that's positive. So we have negative gradient, flat for 0 gradient, and then an increasing for positive. So that's a minimum turning point at 1, -1. And if we look at the graph, we have a maximum into a minimum.